Good morning, students. This is the lesson of class 10 for the subject of geography, topic interpretation of topographical map, part 3 or session 3, which is covered in chapter 2, interpretation of topographical maps, part 2, starting on page number 32 of your textbook and is being submitted to you on 26th of April 2021. Students, in the previous session, we had learned to find out the direction of flow of a river. Now, let us discuss to identify few more features. First of all is identification of left and right bank of a river. For that, first of all, we have to find out the direction of the river. So with the spot heights are decreasing towards the west, the direction of the river is now this is the actual picture. Here, the spot heights, it is 180 nearby this river. It goes to 167 here and 177 in between. So obviously, now the spot heights are decreasing towards the west direction. It means the direction of flow of this river is towards the west. Towards the west direction. So now, to find out or identify the left bank and right bank of a river, the only way to determine left and right bank of a river is to imagine standing in the river facing downstream. It's like so. This will be the direction. Now you are going to turn the sheet the way from the source of the river towards downstream. Okay, so I had turned it like this. Now the places lying on the right side, on your right hand, is part of your right bank tributaries, and places lying on the left hand are the left bank of the river, not tributary. So here, this village lies on the right bank of this main river. Similarly, this one, whereas this particular village lies on the left side or left bank of the river. I hope you understood with this. The next thing is a river island. So as you can notice, a white patch lying within this particular river. So river island show up as a white patch with a black border and occur in four-figure grid reference. So this will be one of the river island. Next is the channel features. In hilly regions, the stream have narrow channel running through V-shaped valleys. When a river passes over an escarpment, it will lead to the formation of waterfalls. Now children, let us discuss about the drainage patterns. Drainage of an area is concerned with the study of main rivers and their tributaries. with respect to size, number, slope of valley. On a topographical map, seasonal rivers are shown with black colored lines. These have a variety of patterns, such as number one is the dendritic pattern. It is a dendritic. It is a branching tree-like drainage pattern which occurs in flat land. Second is trellised. It is a rectangular drainage pattern with streams flowing parallel to each other. These are the streams joining the main stream and joining the main stream at right angle. The third one is the radial drainage pattern. It is a drainage pattern with streams spreading out in all directions like spokes of a wheel. It is found at the hills. So here the streams are moving in all the directions from the central hills. This is termed as the radial drainage pattern. And the last one, the fourth, is disappearing streams. When rivers or streams do not have enough water, they dry up or disappear. These are indicated by broken lines and occurs in sandy desert region. So it was continuous up to a certain time and then started disappearing. So let us see them on the topo sheet also. So as you can notice, here this is a central hill region and the rivers or the streams are flowing in all directions from the center. This is being termed as your radial drainage pattern. Similarly, we have radial drainage pattern here. Okay, class? The other may be like as if you can notice here, the streams are joining the main stream at almost right angle. So this will be a trellised pattern. This is a trellised pattern. Now this is a picture showing the dendritic drainage pattern where the streams looks like the branches of a tree. Yes, and here it is the disappearing stream as if it becomes dotted as it gets evaporated. The amount of water is very less in the river, that's why it gets evaporated. So here they are, the disappearing streams. I hope you understood with this. So now coming to our next topic, that is measurement of distance and area. Now there are two ways to measure the distance of a place. First is the straight distance or the direct distance, and the other one is the along with the car track or any road or something. So the first one is the straight distance. It is also known as the shortest distance, direct distance, or distance as the crow flies. For example, you have to find out the direct distance between Uchawada and Panthwada, Kuchawada and Panthwada. So first of all, we have to find out the midpoints of both the settlements. Then take a strip of paper, as I had taken here, and mark the midpoints on it, as if it is being marked by me here and here. I had marked it on this strip of paper. Now, place the paper on the graphical scale. Now, here I had placed it on the graphical scale. Of the map towards the right side from 0 and measure the value which will be your answer. As if I had done it here, it will be 0, 1, 2, 3, 4 and 5. Now the distance is almost quite comparatively more than that of this much, 5 kilometers basically. That's why the remaining part is being measured on the right side of this graphical scale. So here it is. It was almost. This is here division 1, 2, 3. So the distance between Panthwada and Kuchawada, or the direct distance in between them, is 5.3 kilometers. Right? So the direct distance in between these two places is 5.3 kilometers. I hope you understood with finding out the direct distance between two places. So let us resume and discuss about the second way of finding out the direct distance. The distance between two places. Now here you have to find out the distance between Jubol and Arniwada. Where it is the place named as Jubol, and here it is Arniwada. So you have to find out the distance between these two places along the cart track. As if you can notice, it is a red color line showing. Okay, this red color line, single line, represents the cart track. So you have to find out the distance between these two places along the cart track. For that, first of all, for measuring distance along a metalled road, unmetalled road, cart track, footpaths, rivers, we use a twine. So make a knot on one end of the twine, as if I have done it here. This is a knot I had made, and place it on the point from where the measurement will begin. The twine is bended over the curves. So you have to bend that at every curve. It has to be bended at every curve like this. It is marked where measurement of distance ends. So here I had marked it with a pen. Then the twine should be held straight along the graphical scale, similarly as we had done for the straight distance. Then the twine should be held straight along the graphical scale of the map, and distance is read in centimeters or kilometers, right? So this is the way how could we find out. So it was just similar as we had done with the direct distance in the graphical scale. Here, similar as we had done it here. Now the next thing is to find out the area on a topo sheet. There are two methods which we will use to find out the area on a topo sheet. The first one is counting the grid squares. This is a very simple method. Each grid square has a side of 2 centimeter. Every grid used to have a side of 2 centimeter. 2 centimeter here and similarly 2 centimeter this. Now, which is equivalent to 1 kilometer. So, as per the statement of the scale, 1 centimeter on the map represents 1 kilometer, sorry, 2 centimeters, 2 centimeters on the map represents 1 kilometer on the ground. So, obviously, every grid or every side of a grid is of 2 centimeter each. Hence, they are equal to 1 kilometer. Therefore, the area of each grid square is 1 kilometer into 1 kilometer, which is equal to 1 kilometer square. So, the area of, suppose, this grid square is 1 kilometer square. For example, here you have to find out the area between Northing's 92 to 97 and Easton's 80 to 85. So here what we are going to do to find out the area of this, highlight the bounding lines with a pencil as if it is being done by me here with the red pen and count the grid squares. As you can count it like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. So now we had counted the grid squares and there are 25 grid squares. So the answer of this question, that the direct distance, sorry, the area of this region is 25 kilometers square. I hope you understood with this. It is very simple how to find out it. Next is the second method. Now for that, if we have to find out the area in between the Northings and Eastings, the answer almost the question is the same, 92 to 97 and 80 to 85. Now what we are going to do, we are going to find out the difference in between these two. So that will be 97 minus 92, it will be 5. Similarly, 85 minus 80, that will be again 5. Now, simply 5 multiplied by 5. This 5 and this 5 being multiplied, and your answer will be same, 25 kilometers squared. So you can use any method of your choice. Now, students, this is the question time. So your questions are, first, which landform feature is formed in grid square 9381. Question number 2. What is the drainage pattern in grid square 9284? Find question number 3. Find out the area between 94 to 97 easting and 78 to 81 northing. You can use this topographical map to find out their answers. So the first question was the landform feature present in the grid square 9381. So this is the grid, and here the landform feature is a river island. Second is the drainage pattern in 9284. So here it is. As if you can notice, the rivers are moving out from a central region outward. So this will be your radial drainage pattern. Understood? Your third question was the area between 94 to 97 eastings and 78 to 81 northings. So for that, 97 minus 94, that will be 3. 81 minus 78, again 3. Now 3 is multiplied by 3 and we get the answer as 9 kilometer squares. I hope you understand with this topic.